Dear students, today we will see another chapter which was related to the mechanical properties. In the previous chapter, we had seen something about the mechanical properties of solids, where we had seen different properties. Okay. Similarly, in today's class, we will be studying something about mechanical properties of fluids. So, what are these fluids? We will see the properties and other things one by one. Before that, we will have a clear idea about these fluids. So anything that can flow are called as fluids. In a very simple manner, we can say anything that can flow are called fluids. So what are the examples we can give? We can give very simple examples which are very familiar to you. Are nothing but liquids and gases. Correct, right? So you people all drink water, right? So water is a liquid, and we take air. Air is nothing but it contains a mixture of gases, like 70% of nitrogen and oxygen remaining, carbon dioxide. Okay, so that is nothing but the air, which is mixture of gas. Now we will see the importance of fluids. Why we need to study about the fluids? So if you analyze, we know that the atmosphere, whatever we have around us, is completely the air, which is a fluid. Correct? So whatever atmosphere around us is a fluid, and earth has an envelope of fluid. And if you consider the water level, see, if you take the earth, 2/3 of the earth contains water itself. 2/3 of the earth, whatever matter present, is nothing but water or fluid. Correct? Okay. Now, if you consider the human body itself, see, 60% of human body is nothing but water. Okay, and if you take the weight of an adult, like a matured adult, the 10% of the weight of an adult is nothing but the weight of the fluid, whatever present inside the body. Okay. Next one, we will see the difference between solids and the fluids. So we know, we have a complete idea what about these solids, and we have seen the mechanical properties of the solids. Okay. Now we will compare it with the mechanical properties and other things of the fluids. So we will consider over here. Okay. So let me take a solid and a liquid and a gas. Now see, these two comes under fluids, and this is nothing but solid. So when you compare the volume or shape or size, whatever, we can say solid has a definite shape and it has a definite volume. See, if I consider this chalk, it has a definite shape as well as it has a fixed volume. It has a fixed volume. Similarly, if I take some water, see, water doesn't have any shape, right? Yes, we cannot design any particular shape for that. If I take water in a container, like if you take in a glass, okay, if you take water in a glass, what is the shape of the water? It will occupy the shape of the container or the glass. If you freeze it, and if you can remove this water, okay, you will get the ice, right? Ice will have the shape of this glass. So fluids, they don't have a particular shape. What about volume? So if you consider the volume of liquid, volume of the liquid is nothing but volume of the container in which it is contained. Correct? What about gases? It's a very interesting thing to know about gases. Gases, we cannot assign any shape, or we cannot have any volume also. If I fill some gas, let me take some oxygen or something, and I am injecting into this container, what happens to the volume of this gas? So entirely it is going to spread, okay, entirely into this container. And whatever volume we can assign, it will be the volume of the container, and gases cannot have a particular volume. So whatever volume we assign to the gas is nothing but the volume of the container. Okay. So that was the difference between the solids and fluids. Now how this fluids depend on the external pressure. So what actually happens to the external pressure? See, whatever pressure we feel over here is nothing but the pressure exerted by the atmosphere on our body. Correct, right? So if you go to some Himalaya or somewhere, we say that the pressure on those particular areas are less. Correct? You will find it difficult to breathe. In the previous class, like in the solids, I have told you something like you people they take some tablets and other things so as to control their breathing. The problem is that when you go to high altitudes, the atmosphere goes on decreases. Correct? So if you take this as a sea level, and up to here we have the atmosphere. You know, like troposphere, stratosphere, all those atmosphere. Okay, different layers, and you can see like some kilometers. Let me take some height of the mountain. That's what we discussed in the previous chapter. Was like 8 kilometers, right? So let me take 8 kilometers. So from where I'm measuring this actually? I'm measuring from the sea level. Correct? So as I go to higher and higher altitudes, what happens? Atmosphere decreases. Correct, right? So whatever number of molecules of these gases is going to get decreased. Then what happens? The pressure experienced by a person who is at particular height will be different from the person experiencing the pressure at the sea level. Okay, so it will be different. Now, if this person goes into the sea, like some depth, then what actually happens? Pressure is going to get increased. That we will see later. Okay, so what happens? A person inside the sea will experience more pressure. So you people must have heard something like the walls of these submarines are made very strong, okay, so as to withstand the pressure experienced at a particular depth. Okay, so depends on external pressure. If you apply some pressure on this solid, what actually happens? Say I am applying pressure on this. What actually happens? It will have a very high resistance to the change, right? So whatever we studied, the stress and other things, so it will have a very high opposition for the change in the shape or size or even the volume. Correct? So it is difficult changing the volume of the solid. You have to apply very high pressure. Similarly, if you take liquid, so if you want to compress this water, still it is very difficult. Okay, you can understand that if you want to compress, see, even if you apply high pressure on the water surface, it is not that easy to compress it. Okay, so water is all, liquids are also highly incompressible, like solids. What about gases? So gases you can easily compress. If you take a piston or something like this, okay, and you are filling some gas on this one, and you apply some force over here, so that the piston moves downward, and what actually happens? The molecules are going to come closer, and you can make this as liquid. See, this is what you see in your house, the LPG cylinder. See, they are not filling liquid into the LPG cylinder. Correct? What they are filling? They are actually filling the gas, the petroleum gas. But you should see the container thickness or the strength of the container. It is very strong. Correct, right? So with the high pressure, they are compressing this gas, okay, to a particular amount, whatever weight they assign, okay, and it will be stored in that gas cylinder in the form of liquid. If you just shake the cylinder, you can feel some kind of movement of water inside. Okay, so the gas, how it becomes gas actually when you open it or when you release the gas, when you open the knob of that gas cylinder, how it becomes like what actually happens there? The liquid, okay, the gas liquid present inside, when exposed to the atmospheric pressure, so inside pressure is very high, okay, outside pressure is very low compared to the inside pressure. Then what happens? This liquid actually becomes gas. Okay, so I mean to say that gases are highly compressible. So gases can be compressed also in another manner by decreasing the temperature. By decreasing the temperature, you can compress gas. What actually happens when you decrease the temperature? When you decrease the temperature, these molecules will come closer and closer. Then what happens? It will occupy the it becomes a liquid, other than when it is previously a gas and it is cooled, it becomes liquid. So molecules are going to come closer. So this is what you have studied in your 10th also, right? In the solids, molecules are very closely packed, correct? Then in the compared to solids, in liquids, they are a bit loosely packed, okay? But in the gases, they are very loosely packed. If you take certain volume, then the number of molecules you can see will be maximum over here, and comparatively less in this one, and very less in the case of gases. Next one, you can see the dependence on shear stress. How these fluids depend on shear stress. So shear stress, you know, right? What is actually shear stress? I told you in the previous chapter, if you take a book and you apply a force on the top of that, correct? You apply force on the top of that, then what actually happens? The lower part will be fixed, okay? It is not going to move, it will be fixed, and the upper part is going to move slightly. So if you take a solid, okay, what actually happens? They cannot be displaced with a large amount, right? You can only, there is a possibility you can slightly move the top part, fixing the bottom part. But when you take this liquids and gases, they have very less value of shear stress, because if you apply very less force, okay, it is going to get displaced. So you can just do an activity like you can take a balloon and you fill water into it. Then you apply force on the top of that, keeping the bottom fixed. See, it moves without even applying large force, like not even large force. Very small force is enough to move the upper part, keeping the bottom part fixed. So I mean to say that these fluids are having very less value of shear stress, and if you compare it with solids, it is a million times, okay, it is a million times smaller than that of the shear stress of solids, okay. So I hope you have got some kind of idea related to these fluids. Then what you need to do is read NCERT textbook, okay. Read this book, maybe if you don't understand, once you read for the first time, you read it twice. Even if you don't understand, you read it thrice, okay. Then you will have a clear idea about this subject. And they are really good NCERT textbook. And if you are really good at this subject and you can understand very easily, you can go to this H.C. Verma book. There are 2 volumes of H.C. Verma, and you will get higher level ideas which will help you in your NEET or this JEE examinations. Okay. So we will begin this chapter knowing about pressure. Okay. So average pressure, we say that it is a ratio, okay, of normal force and unit area, or we simply say that normal force acting per unit area is known as average pressure. So pressure we can understand very easily. I'll take this chalk and I'll press it on my hand. What actually happens? See, nothing happens. I'm not getting hurt, right? So you can see this, I'm not getting hurt. At the same time, if I take this pen and if I just press it like this, I'm getting hurt. So what actually happens over here? Why I'm getting hurt when I take this pen, why I'm not getting hurt when I take this chalk? See, I'm applying equal force. I'm not applying different force. See, you see in front of you only I'll apply the force. See, I'm applying this much force. Okay, I'm not getting hurt. But if I apply same force, I'm getting hurt. So what actually different in these 2 cases? So the difference is nothing but the area where this force getting acted. Correct? So when I apply force with this chalk, actually up to this much area, you can see this. See, the force whatever I explained was distributed up to this area. But if I consider this chalk, you see this, compared to this one, the force was getting acted upon in the very small area. So effect of force will be more when there is less area. Okay, so this pressure actually depends directly on the area on which the force gets acted upon. So we can have a simple device over here to understand how this works, or how we can measure this. Let me take, see, this is an imaginary instrument, okay, not actually the perfect one. It's an idea what we developed. It's fixed with a spring, not a string, sorry. It's a spring, and whatever inside here is vacuum up to this. Nothing is present inside it, vacuum. And I'll keep it inside a what? Inside a beaker. Or even if you can keep in the atmosphere also, you can understand the pressure exerted by the atmosphere on this spring. Okay, it has measuring units, like we will have some reading and other things. So, see, this is the area assigned. See, up to this area the force will be getting acted, and we will take it like a unit value, particular unit value. That's the reason why it is written normal force acting per unit area. Okay. Now, if I keep it in the atmosphere, what actually happens? Atmosphere is going to exert force on it, and this spring is going to get compressed. Okay. If I take it from vacuum to atmosphere, vacuum, there is no external force. Okay. So if I keep it in the atmosphere, it is going to experience some force, and we can measure that force. Similarly, if I keep it inside the water, then what happens? The water is going to apply some force on this one. Then what happens? It is going to get compressed again, and we can measure the value of it. So it is an idea where we say that this can be an instrument which will be used to measure the pressure. Now we will go to some more idea, like making this instrument very small in size. Very small in size means what? We will make this area nearly zero. If you make this area nearly zero, then you know, right? When area decreases, what happens? The pressure, whatever experience on that part, will be increased. Correct? So pressure experience or the force experienced on that particular area will be increased when we decrease the area of it. Now, I can say that the limiting value of this area, where I say it is a pressure, that can be written as P is equal to limit delta A tends to 0 delta F by A. So this is the limiting value of pressure. Okay. Then what we need to understand, pressure is a scalar quantity. So even though you see here a force, and we know that force is a vector quantity, but this pressure is not a vector quantity compared to other stresses. So you will get a very clear idea why it is a scalar quantity. You know, right, what is scalar quantity? A quantity which depends only on the magnitude, not on the direction. That means pressure acted on a particular object is same from all the directions. Okay, then we say that it is a scalar quantity. Then SI unit of this pressure is nothing but Newton per meter square, or it is also called as Pascal. So Blaise Pascal is one of the scientists who have contributed its major part of the studies. Okay, so he had done many researches and other things so as to understand all these phenomena, and also his helps, whatever he had done, we are very grateful to the present generation. So that's the reason why we can understand all these things properly. So on honor to him, we have kept this name, okay, for the SI unit as Pascal also. So other unit is nothing but Newton meter square. Then we have a common unit for this pressure, that is nothing but atmosphere, or we call it as ATM. So this 1 ATM is the pressure exerted by the atmosphere at the sea level. So what is this 1 ATM? 1 ATM is nothing but pressure exerted by this atmosphere at the sea level. That's what I told. A person on the sea level will experience different pressure compared to a person who is on some mountain. Okay, so those people at a very high altitude will experience less pressure, okay, than the person who is standing on the sea level. So this 1 atm can be written as, it is nothing but 1.013 into 10 to the power 5 Pascal. Okay, 1 atm can also be written as 1.013 into 10 to the power 5 Pascal. This value has to be remembered for solving problems. It's very, very important. Okay.